Random search CV. What is random search CV? Random search CV is a hyperparameter tuning technique. It randomly samples of combines of hyperparameters and evaluates them using cross-validation to find the best composition for a model. Where we use real-time projects when the number of hyperparameters is large, when some hyperparameters have more impact than others, when the parameter space is continuous or very large, when computational resources are limited, compares to grid search. In NLP, computer vision, recommendation system, time series forecasting, etc. For models you use for tuning random search CV. Linear regression, rigid lasso, electric net. Logistic regression, decision tree classifier. Random forest regression classifier. XGBoost, CatBoost, SVM, KNN, neural networks, deep learning models, naive bias, gradient boosting, etc. Why is it important? Improve model performance by finding optimal hyperparameter. Save time compared to grid search. Works well with large hyperparameter space. Helps in building generable models. Advantages: more effect than grid search. Works better with large search space. Faster execution. Can find good convolution even with limited interaction. Easy to implement. Disadvantage: no guarantee to find the best convolution. Results may vary. Grid search CV is a hyperparameter tuning technique that trail all the possible combinations of hyperparameter from a predefined grid using cross-validation to find the best combination for a model. Why is it important? Through all possible combinations, find the optimal set of hyperparameters, improve model performance, works well. Parameter grid is small, where we use in real-time projects. When the number of parameters is small, we want to fine-tune model performance in projects where accuracy is critical. When computational resources are strict. How it works: find a grid of hyperparameter, train the model for all possible combinations, cross-validation to evaluate each combination, select the best combination with a high score. Model we can tune using grid search CV, linear regression, logistic regression, decision tree, random forest, SVM, KNN, XGBoost, neural networks, naive bias, etc. Advantages: find the best combination of systematically. Works well for small parameter space. Easy to implement. Improve model performance. Disadvantage: computationally expensive, large parameter grid, not suitable for large datasets. Time consumed.